Hello, in this video we're going to cover examples of BigO. As you can see, I've written out the list that we created last time, and it would help you to memorize or at least be able to derive this list. And if you want to know how to do that, you can watch the last video, in which case we walked through finding all of these and how they relate to each other. I'll leave the link to that in the description. So let's dive in. We want to know if this expression, that's 20x cubed plus 10x squared plus 100x plus 3, is that an element of BigO x cubed? So this is asymptotic notation. The first thing we do is we ignore all the constants. So we'll get rid of 20, 10, 100, and 3. And we're left with x cubed plus x squared plus x. Secondly, since we're adding these, we can get rid of all of the lower expressions. So we only care about the highest one. So x is less than x squared, so we'll get rid of that. X squared is less than x cubed, so we'll get rid of that. X cubed seems to be the highest here, so really what we're asking is x cubed an element of BigO x cubed? What that's asking is x cubed less than or equal to x cubed? And they are equal, so that is true. So this whole expression, 20x cubed plus 10x squared plus 100x plus 3, that is an element of BigO of x cubed. So that trick works well for addition and subtraction, but what about multiplication? So here we want to know if x log x is an element of BigO x squared. To solve this, I've rewritten it as x log x is less than or equal to x squared, and this is the question we're asking. I'll start by doing it algebraically. Divide by x. You get log x is less than or equal to x, and we can look at our comparison, and that is true. Log x is less than or equal to x. So this is also true. But what if we have addition and multiplication, and some term that we don't know? We can work out this by combining the two methods. The first thing we do is we'd ignore any constants, but in this there doesn't seem to be any coefficients that we can ignore. So we will just rewrite the problem and ignore the lowest term. So the first thing we're going to do is determine if this is greater than this or if it's the other way around. So to do that, if we multiply something by x, it gets larger. X factorial is already way larger than x log x. So this is larger than this. So that term is smaller. Now we get x times x factorial. And we can use our algebra tricks with this. We divide by x factorial. Those go away. This will go away. And you're left with x is less than or equal to 1. That is true. So this expression is BigO of x squared. Before we wrap up, a quick note. Sometimes you'll see this notation instead of the is an element of. This equals is a little abusive because x does not actually equal BigO of x squared, but we use it to say x is an element of BigO of x squared, or x is order x squared. So that's just a different way you'll see it, a different way you'll hear it, but it's still the same process that we've been doing. So that's how you figure out BigO notation. You ignore the smaller terms, you ignore constants, and then you use algebra to work out the rest. Also note that any element is BigO of itself. So if we have x that is BigO of itself, x squared is also BigO of x squared, and so on. Stay tuned, and I'll see you next time.